Example 4, converting from rectangular to trig form, use radian measures for -3 plus I in trigonometric form. Okay, so here we go. Writing this in trig form. X is negative. Whoops, typo error. In your notes, this is supposed to be a negative square root of 3. So that's what my x is supposed to be. This is a typo error. Please fix it. The y is a 1. I apologize for that symbol. Again, my apologies. When I did a cut and paste, the square root symbol disappeared when I go from a Word Google Doc to regular Word. All right, so the next thing I want to do is plot this point. Negative x, positive y. That puts me over here in quadrant 2. So I'm going to build myself a vector out to -3, 1. And so now that informs me that the theta has to be from 90 to 180, which then I'll convert to radians. I prefer to work everything in degrees because it's easy to identify angles with my calculator. R, bring in that square root of x squared plus y squared, so the square root of 3 squared, which will be 3, plus 1 squared is 1, that's a 4, square root of 4 is 2. Now my theta, inverse tangent of y over a negative square root of 3. I'm going to go to my calculator for that. Type it in, I get a negative, wait a minute, negative 30 degrees. Oh, well, yeah, that's right. Remember, we talked about inverse trig functions. When the argument is positive, we're all up in quadrant 1. But when my inverse tangent has a negative argument, I'm down in quadrant 4. So that's this negative 30 degrees. But to get to quadrant 2, I add 180 degrees to that. So, yes, the inverse tangent is a negative 30 degrees, but my theta is 150 degrees. Okay, so now, wait a minute. This has to be in radians, so let me put that 150 degrees into radians. So 150 over 180 reduces to 5 over 6 times pi. Okay, 5 pi over 6. So your R value, 2, times cosine 5 pi over 6 plus I sine 5 pi over 6, or shorthand notation, 2CIS 5 pi over 6. Quick and easier to write. Okay, B, write -3i in trigonometric form. We're going to use degrees. All right. So notice there's no real number. No real number like we had up here for the negative square root of 3 again. Again, I apologize for the typo error. So that would be x is 0, and my y is the -3. Well, wait a minute. That's on the negative y-axis. Okay, so that just simplified things for me. My r is the magnitude of this vector. It's 3 units long, so r is 3. And since I'm on the negative y-axis, that's, okay, here's 0, 90, 180, that's 270. Theta is 270. I can go right to writing my trig form. 3 cosine 270 degrees plus I sine of 270. Or, quick and easy, 3 CIS 270 degrees for my trigonometric form. Example 5, converting from trig form to rectangular form. And the first thing I want to talk about is you're going to get 2 types of questions. Where you have theta, that you have your special right triangle angles, multiples of 30, 45, and 60 degrees. And then you have your calculator angles. These are the ones you cannot simplify by your special right triangles. You have to use your calculator. So here, first thing I notice, 300 degrees. That's a multiple of 60 degrees. Probably a 60-degree reference angle somewhere. 3 pi over 4, my denominator of 4, that's a 45-degree reference angle in some quadrant. So when we get there, we'll draw this stuff out. So again, 300 degrees, xy coordinate plane, wrap it all the way around. There's my complex number graphed. Well, if this is 300, that's a 60-degree reference angle. And wait a minute, hypotenuse of 2. Hey, this is the 30, 60, 90 right triangle with its triple ratio. Opposite of 60 is square root of 3, but because I'm below the x-axis, that's a negative. And this would be 30, and opposite of 30 is 1. So I can use now this right triangle to evaluate these trig functions. So to put this in rectangular form, I got to find x. R cosine theta. I have to find y. R sine theta. So 2 times the cosine of 300 degrees and 2 times the sine of 300 degrees. Okay, well, let's take a look here. Cosine adjacent over hypotenuse. We'll change cosine of 300 to a half. Sine of 300, opposite, negative square root of 3 over 2. Replace sine of 300 with negative radical 3 over 2. Cancel the 2's, cancel the 2's. X is 1, y is the negative square root of 3. My rectangular form, or a plus bi standard form, 1 minus I radical 3. Again, always put the I in front of the square root of 3. Okay, let's see. Radians, pi over 4, that's a 45-degree angle. I have 3 of those. 1, 45, 2, 45, 3, 45. So xy coordinate plane, right triangle right here. Let's see, 3 45s is 135 degrees with a 45-degree reference angle. And my r value, my hypotenuse, my magnitude of my vector, if you will, is a 2. Oh, wait a minute, that's supposed to be the square root of 2. Okay, so we may have to work this out here differently. Let's see. So x, 2 cosine 3 pi over 4, or theta, if you will. Just copy those down here. So I prefer degrees, 135 degrees. That tells me that's this 45-degree reference angle. So cosine, whoops, wait a minute, that's negative x's. This will be a negative square root of 2 over 2. And this 45-degree reference angle is going to be for sine, the square root of 2 over 2. 2 on the outside cancels with 2 in the denominator. Same over here. X is a negative square root of 2. Y is a positive square root of 2. Put it in my a plus bi form. Negative square root of 2 plus I square root of 2. So these were our special right triangle examples. Example 6, this one's all about the calculator because we don't get those special multiple angles of 30, 45, and 60. Ends in a 5, you can divide it by 45, but it doesn't go in evenly. All right, so here, this one we're going to change to rectangular form like we just did with the other two. Here's rectangular form that's going to be changed into trig form, but again, we're not going to get a nice special right triangle theta. So just like we did back here, grab those rules right there. R cosine theta is x, R sine theta is y. Let's crunch the numbers. 6 for the R, 115 degrees for the theta. 6 for the R, 115 degrees for the theta. Go to your calculator, and now what do? Is I type in 6 cosine of 115 degrees, get my answer, up arrow back to this, cut and paste it to here, put your cursor on the C and type in the sine button, and then you have this function, and type it in. So there's my answer. So I took this one to 4 decimal places. My x is negative 2.5357. My y is 5.4378. So multiply the y by the I, and you are now in rectangular form or standard form. B is in rectangular form, which means we want to turn this into trig form. So x is 5, y is negative 4. Well, let's see, that's a positive x negative 4. I'm down here in quadrant 4. Now, the reason I want to know that is, again, because I'm probably going to have to use my inverse trig function. So I'm probably going to have a negative, which I do, the negative 4, and I'm going to get a negative angle down there. So r, x squared plus y squared, okay, 5 squared, 25, negative 4 squared or 4 squared, 16, added together is 41. There's your r value. Theta, inverse tangent of y over x, negative 4 over 5. Calculator! Calculator tells me that's a negative 38.66 degrees. Now, notice I added 360 to it. Reason being is if the directions tell you that theta has to be between 0 and 360, we don't want the negative angle. We'll add 360 so we come back to quadrant 4, but with a positive angle. So, my trig form, r square root of 41, CIS 321.34 degrees. There's the shorthand form for the trig notation.